Okay, so in this lesson, you want to determine whether two lines are parallel lines, perpendicular lines, or neither. And in these examples, you're actually given equations of lines. So remember in previous lessons that parallel lines have the same slope, and perpendicular lines have slopes that are opposite reciprocals or negative reciprocals of each other. And another way of saying that is that two lines are perpendicular if the product of their slopes is -1. So in these problems, for the most part, you're going to be looking at slopes. You're going to be finding the slopes. Well, if you look at number 1, you're given that line 1 has this equation, and you're given that line 2 has this equation. First thing you have to recognize is that those equations are both in slope-intercept form. They are in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where the coefficient of x is your slope, right? That's your slope. And the constant is your y-intercept. This would be your y-intercept. But in these problems, you're just interested in the slope. So if you look at line 1, this is line 1, you have this equation which is in slope-intercept form, and the coefficient of x is a -3. So the slope here, so here's your work. Let's do this. This is the work. So the slope of line 1 equals -3, right? And then the slope of line 2 equals the coefficient of x, whatever you multiply an x by, so that is 1/3. Now, once you find the slopes, you compare those numbers. This is -3, this is 1/3. They're not parallel because they have to be equal, but are they perpendicular? So look to see if they're perpendicular. The reciprocal of 3 is 1/3, and then ask yourself, is it the opposite reciprocal? So if this is negative, this has to be positive. So yes, they are opposite reciprocals of each other. And if you multiply them, just want you to see this, if you were to multiply through -3 and 1/3, -3 times 1/3, you get -3 divided by 3, which is a -1, right? So their product's -1. If the product's -1, if the product of their slopes is -1, the lines are perpendicular. Okay, so since the lines, so L1 and L2 are perpendicular. Okay, and you have to explain why. So there's the work, and you can say this. You can also say L1 and L2 are perpendicular since the slopes are opposite reciprocals of each other. Opposite reciprocals. All right, but you have to tell me. See, you got to indicate. You can't just say they're perpendicular. You got to explain why. So the reason is the slope of line 1 is -3, and the slope of line 2 is 1/3. So those are opposite reciprocals. Okay. All right. So make sure you do that. Okay. Now in number 2, line 1 is in slope-intercept form. So that's easy to determine the slope. But look at line 2. That is not slope-intercept form. So we have to get y by itself. So let's put this in slope-intercept form. So this is going to be your work. And put this here. So there's the work right here. So let's put this in slope-intercept form. So 10y minus 2x equal -7. So I'm going to add 2x to both sides. So this is 0. -2x and 2x is 0. So get 10y equal 2x minus 7, right? And then divide both sides by 10 to get y by itself. 10 divided by 10 is 1. 1 times y is y. So I get y equals 2/10 x, right? This is fractions. 2/10 x minus 7/10. Reduce the 2/10. So that's y equals 1/5 x minus 7/10. Okay? All right. Now, once I get to that point, then you're going to say this. The slope of line 1 is equal to what? Coefficient of x. See, this is already in slope-intercept form. So that's 1/5. And we just found that the slope of line 2 is what? 1/5. So this equation and this equation are equivalent. So therefore the slope of this is the same as the slope of this. So that slope here is 1/5. What do you notice by those two slopes? They are equal. All right, so you're going to say since the slopes are equal, Since the slopes are equal, you're going to say line 1 and line 2 are parallel. Okay? All right, line 1 and line 2 are parallel. Now, I'm just going to say this as well. Sometimes note, you could say this: since the slopes are equal, line 1 is parallel. That's a symbol for parallel. It's like two little slashes parallel to each other. Line 1 is parallel to line 2. So the phrase here, line 1 and line 2 are parallel, can be written like this. Okay? And then we could have said the same thing here. So note, you could say this. You could say, that's a note. You could say line 1 is perpendicular. That's the symbol for perpendicular right here to line 2. Okay? You just got to make sure that I can recognize that's perpendicular and I can recognize that's parallel. So just to remind you about the notation, the symbols. Okay, that was number 2. All right, let's look at number 3. Number 3. All right, now when we look at number 3, you're going to notice something. You're going to notice, well, first of all, there's no y there, right? There's no y, so I cannot write this in slope-intercept form, right? There's no y. But I can still answer that question. I can still answer this. Determine whether the lines are parallel, perpendicular, or neither. I can answer that. All right, let's think about this. What kind of line is x equal 5? X equal 5 is a vertical line, right? X equal 5 is a vertical line. So I want you to remember that. X equal 5, let's go ahead and look at in terms of a grid. So x equal 5 is right here. This is x equal 5. Okay? So no matter where you are on this line, x is always equal to 5. This is x equal 5. If you look at the next one, x equal 2, here's x equal 2, right? X equal 2. It's also a vertical line. And what do you notice about those two lines? Are those two lines parallel, perpendicular, or neither? They are parallel. You couldn't do it using slopes. You could not do this using slopes because those two lines have no slope. The slope is undefined, right? Slope is undefined. So since the slopes are undefined for both, remember they're vertical lines, right? Since the slopes are undefined for both, they're vertical lines, the lines are parallel. Okay, you could not use slope here. You could not use slope. But we do know that those lines are vertical lines. We do know that those lines are vertical lines. There is no slope. So those lines are vertical lines, and we can see that those vertical lines are parallel to each other. Okay? So since they're vertical lines, they are parallel. All right. Now, number 4. Okay. Let's get x by itself here. So first of all, here's your work. This is the work. So this becomes x equal 7, right? 14 divided by 2, x equals 7. All right, now, this line, x equals 7, there's no y value, so x equals 7, that's a vertical line, correct? That's a vertical line, right? So it has no slope. It has no slope. The slope is undefined. Slope is undefined. This line right here, y equals 3, that's a horizontal line. And we know the slope of a horizontal line is 0. So this slope is undefined, this slope is 0. But in particular, I did not even need to use this. I did not need to use the fact that the slope is undefined. I did not need to use the fact here that the slope is 0, because I know whenever x is by itself and there's no y, I know it's a vertical line. Whenever y is by itself and there's no x, I know it's a horizontal line. And so when you have a vertical line, look like this, and you have a horizontal line, they're going to intersect, and they're going to intersect at a right angle. And so since those two lines intersect at a right angle, this is line 1 and this is line 2. Since those two lines intersect at a right angle, those two lines have to be perpendicular. All right, so the lines, so let's say this, line 1 is perpendicular to line 2. All right, and let's look at that in terms, I just want to show you, let's look at that in terms of this graph. All right, so x equals 7, remember how to graph this, so that means that x always equals 7. So that's going to be here. X always equals 7, so that's a vertical line. Y equals 3 means that y is always equal to 3, no matter what x is. So y equals 3 is this horizontal line right here, right? So this is x equals 7, this is y equals 3. When they intersect, they intersect at a right angle. So since they intersect at a right angle, that means that those two lines have to be perpendicular. Okay, so they're perpendicular. All right, so that's number 4. All right, number 5, and then finally let's look at number 5. Okay, so notice again you have that special case where one of the variables is missing. Don't let that throw you off. Think about something you did in the past. You know about this. Nothing is new here. You can handle this. So your work here, you can get y by itself. So if y plus 6 equals 0, then that means y equals negative 6, right? So I have y equals negative 6 and I have y equals 3. Notice there's no x. So that means y always equals negative 6. Here, that means y always equals 3. Whenever you think like that, y always equals negative 6, y equals 3, do you remember what kind of lines those are? Y equals negative 6, y equals 3, what kind of lines are those? Those are horizontal lines, right? And a horizontal line, you could have also said the slopes are 0 because all horizontal lines have slope 0, but you didn't need to know that. All you need to know was that this is a horizontal line, and this right here is a horizontal line, right? And when you think about horizontal lines, look, when you think about horizontal lines, this horizontal line and this horizontal line, let's call that line 1 and line 2. What do you notice about line 1 and line 2? They are parallel. So you can say this now. You can say the two lines are parallel. Okay. Now I just want to show you, if you were to graph this, see what you would get. So look, here's y equals negative 6. Y equals negative 6 is right here. So y always equals negative 6. Okay. So y equals negative 6 is a horizontal line. Y equals 3, the other one, is right here. This is y equals 3. What do you notice about those two lines? Those two lines are parallel. Okay, so horizontal lines that are distinct, see, they're distinct, so they're going to be parallel. All right, these two lines don't intersect. They don't intersect. You don't see them intersecting. So they have to be parallel since they don't intersect at all. Okay. All right. So and that was it. So there's some special cases here. So 3, 4, and 5, you had to think about. Those were special cases where one of the variables was missing, and so you had to think about graphs that you did in the past. So when you graphed these were vertical lines, and so we know that when you graph vertical lines, they have to be, and that's just right here, by the way. So when you graph vertical lines, you notice they're parallel. Over here, this line x equals 7 is vertical, y equals 3 is horizontal, and we now know that a horizontal and a vertical line are going to intersect at a right angle. So those two lines have to be perpendicular. You didn't use in this when I'm discussing this, I didn't use anything about slope. I just use the fact that the lines are vertical or horizontal. And then in number 5, same idea, except this time the two lines are horizontal because they're both y equal a number, and we saw that in this case, these two lines here that are horizontal, they don't intersect, so they have to be parallel. Okay? It was just the first two that we did, where you had to get in slope-intercept form because there was both an x and a y in it. And so you had to use the idea of slope there. Okay? All right, so that is that uh, lesson. So it's not difficult. Just make sure you go back and you look at it. It is not a difficult process, not a difficult concept. All right, so that's the end of this lesson.